Hey everyone, welcome back to ChemCore's Regents chemistry course. In this video, we'll discuss a crucial point of calculation important for almost all sciences, including chemistry. I'll paint the picture with an example. Let's say I give you this box, and I ask you, what do you think the length of this box is? Maybe you'll answer, I don't know, Greg, like a foot long. That's an acceptable answer. But why did you round to a whole number, a foot? Why didn't you say 1.3 feet, or some other oddly specific number? The reason is because you aren't sure. You don't actually know how long the box is, so you're approximating. The cool thing is, if I were to later measure out the length, and it turns out to be 1.4 feet long, I'd say you were pretty close to the true answer. But if you gave me the oddly specific number of 1.3 feet, I'd be like, you're wrong, by a tenth of a foot. This ties into all the concepts we'll talk about today. When you gave me a rounded number, you specifically said 1 foot, not 1.0 feet, or 1.00 feet. Why? Aren't they all the same number? They're all the same, but the decimal points give a precision to your answer that you don't have. By saying 1.0 feet, you're saying that you measured specifically to the tenth of a foot and arrived at that answer, which you clearly didn't. The same goes for 1.00 feet. This idea is illustrated by the concept of significant figures, or digits in a number that matter. Since you rounded to the whole number of 1 foot, you only gave me one digit that matters. Therefore, your answer has one significant figure. If you were weird and gave me the answer 1.0 feet, you rounded specifically to the nearest tenth, so 2 digits in your answer matter. Therefore, your answer now has 2 significant figures. Similarly, 1.00 would have 3 significant figures, 1.000 would have 4 significant figures, and so on. All non-zero numbers like 1, 2, 3, and so on are significant. Also, all trailing zeros, or zeros at the right side of a number, are significant, but only if there's a decimal point. Our previous example, like 1.00, had 3 significant figures. The last 2 digits were trailing zeros, but counted as significant because there's a decimal point. However, if our measurement was 1,000 feet with no decimal point, we would only have one significant figure, because our trailing zeros no longer count without a decimal point. In addition, any zeros between non-zero digits are significant. For instance, in a number 1,207, there are 4 significant figures, with a middle zero counting as significant. Leading zeros in a decimal are not significant. For instance, the number 0.00032 has only 2 significant figures. The 3 zeros in front of the decimal point are not significant, and the zero before the decimal point is also not significant. One final rule remains. Exact measurements, like the measurements of 60 seconds per minute, have infinite significant figures. The reason is because this is an exact standardized measurement, and there's no rounding involved. Let's practice these concepts with determining the number of significant figures for each of the measurements below. Pause the video to try each. Problem A, 14,000 minutes, has 2 significant figures, since trailing zeros without a decimal point are non-significant. Problem B, 98.40 grams, has 4 significant figures, since we count trailing zeros with a decimal point. Problem C, 80 bottles of water, has 1 significant figure, since trailing zeros don't count without a decimal point. Problem D, 0.04509 inches, has 4 significant figures, since leading zeros don't count, but all the digits afterwards do. Problem E, 0.0000345 kilograms, has 3 significant figures, since leading zeros once again do not count. Problem F, 14,000 pounds, has 5 significant figures. This is a trick question, since I sneaked in a decimal point. The trailing zeros now count as significant. The concept of significant figures doesn't really end there. Throughout this course, we'll do numerous operations and equations. We need to understand how to be able to express our answer correctly, showing the correct number of significant figures. For instance, if I have 80 apples and 4 friends, I can share 20 apples per friend. I'd never say 20.00 apples per friend, because I never measured my numbers to 4 significant figures. In multiplication and division, our answer must have the same number of significant figures as the number with the smallest number of significant figures. For instance, if I had 124 apples and 4 friends, how many apples can each friend get? 124 apples has 3 significant figures, while 4 friends only has 1 significant figure. Therefore, our answer must be expressed rounded to 1 significant figure, which would be rounded to 30 apples. In addition and subtraction, we don't care about significant figures, but we care about decimal places. Our answer must have the same number of decimal places as the number with the smallest number of decimal places. For instance, if I measured out 10.5 grams of sugar and then another 5 grams of sugar, how much total sugar did I measure out? Well, we have 1 decimal place in 10.5 grams and no decimal places in 5 grams. So our answer should have no decimal places. Therefore, our answer will be rounded to the nearest whole number, or 16 grams. The description below has practice problems and worksheets available for free, with a video going through the worksheet in case you find yourself stuck on anything. See you in the next video.